So yesterday we went over the 5 reaction types in class. Okay, and we talked about how we write chemical reactions. We looked at balancing chemical reactions, right? So just a quick review, the 5 reaction types. Synthesis reactions, okay? In a synthesis reaction, 2 elements combine to form a single compound, okay? In a decomposition reaction, the exact opposite occurs. We have a compound that breaks down into its elements. We have combustion reactions, where a hydrocarbon, that is a molecular compound containing carbon and hydrogen, reacts with oxygen to produce carbon dioxide and water. Then we have our 2 replacement reactions. Single replacement, where we have an element that reacts with an ionic compound and replaces something in that ionic compound. If the single element is a metal, it replaces the metal in the compound. If the single element is a nonmetal, then it replaces the nonmetal. Okay. And then we had double replacement reactions where we have 2 ionic compounds reacting to form 2 new ionic compounds, and we can do that by simply switching the metals so that they have new partners. Okay, is that ringing a bell from yesterday? Okay, so let's have a look at this first one just to kind of refresh our memory here. What kind of reaction is number 1? It's a decomposition reaction. So first thing we would write, okay, is it's a decomposition reaction, and then we got to write it out in words. So this would be trinitrogen dioxide. Okay, what's this stuff? Nitrogen, right? Just the element. That's how it appears because it's one of the diatomic ones, so it doesn't change its name. Okay, plus oxygen. Okay. Now I need to balance. Since this isn't a combustion reaction, which has its own set of rules, what should I start with? Right, generally we go with the atom that's in the largest number, because typically if you can get the biggest one to balance, the smaller ones kind of fall into place after that. It doesn't always work, but it's good for probably 4 out of every 5 times, okay? All right, so I'm going to start with nitrogen. I got 3 over here, and I've got 2 over here. How am I going to make 3 and 2 balance? Okay, because I'm trying to get the lowest common multiple, which is 6. Lowest common multiple is 6, right? I multiply this one by 2 to get 6, and I'll multiply this one by 3 to get 6. All right, so now how many oxygen does that 2 here give me? 4. So what needs to go over here? A 2. Okay, fairly straightforward. One thing that may come up, sometimes we pick the wrong number, but we still get it to balance. Okay, and by the wrong number, I mean, I may have accidentally written in here and gone, oh, well, I'm going to try a 4. Okay, I'll probably still get this to balance, but there'll be a small problem. Okay, so that gives me 12, so I put a 6 here, and that gives me 8, so I put a 4 there. Okay, can I reduce those numbers? Yes, it happens once in a while. Just be on the lookout for it. Okay, if you've got a whole set of numbers as balancing numbers and you can reduce them down, reduce them down. Okay. All right. I want you guys to try the next 4. Okay, and then I'll go through them kind of one at a time every couple of minutes here, and we'll see how we do. So with number 2, okay, I've got what kind of a reaction here? Number 2, sorry. 3 is combustion. 2 is single replacement, right? I have an element reacting with an ionic compound to form a new element, new ionic compound. Okay, so my single element is a metal, right? So we see that it swaps out with iron. Okay, so iron ends up alone and calcium ends up with chlorine. Okay, so written out in words here, we've got calcium plus iron, Roman numeral 3, chloride. Yeah, probably a few of you forgot to do that. Yeah, and it happens. It's something we got to get in the habit of. Okay, iron plus calcium chloride. Okay, now I've got to, single replacement. Forgot to write that down. Now we've got to balance it. What's our best bet to start with? Chlorine, present in the highest number. Okay, lowest common multiple of 2 and 3 is 6. So I'm going to put a 2 here, okay, and that'll give me 2 irons over there, so I'll balance that right away. And I'm going to put a 3 here in order to get me the right number of chlorines. Then I'm going to come back over here and balance my calciums. All right, so now the whole equation is balanced. So if I asked you to do this on a test, and I will, okay, I would be looking at marks probably something like this. Like you'd get 1 mark for the reactants, 1 mark for the products to be written correctly, okay? And then we'd be looking at probably 1 mark for the balancing and 1 mark for writing the reaction type. Okay, so one like that would probably be at a 4. If I asked you to predict the products, then it would probably be at a 5. Okay, everybody sort of with me on there? All right, would you, if you forgot the Roman numeral, get this mark? Nope. Okay, then you would lose the mark for the reactants because your reactants weren't right. So little things like that, those little details, we want to make sure that we're getting used to using those and remembering that they occur. That's a good question. When iron is by itself, or any other multivalent metal is by itself, I do not need to write a Roman numeral because this is its element form and it has no charge in that form, right? I'll only know it has a charge if it's in a compound, an ionic compound with something else. Okay, so that's a good question. No, you don't need to write Roman numerals, nor should you, on a multivalent metal when it is alone, okay? Just when it's in a compound. All right, how many people have done number 3? Do we need to go over that one? Yeah, okay. Okay, so we said that number 3 was a combustion reaction. We have carbon and hydrogen reacting with oxygen. Okay. For naming, I don't even remember what the prefix is for 14. So I'm just going to write that this is hexane because that's what it is. But I'm not going to capitalize it because that would be bad. I would not give you one on a test that you don't know the prefixes for. That would hardly be fair. So the common name for this is hexane. Okay, plus oxygen. Okay, gives us carbon dioxide and water. And as I think we discussed this yesterday, but just remember, anytime you see water, H2O, HOH, whatever, it's just water, okay? Don't try and figure out a name for it because there's like 4 or 5 different ones that would be correct, okay? Water's fine.
How like high do we know?
10. Yeah, just a 10. Yeah. Like I say, if it's on a test and I give you this, I would give you the name of it, right? Or I wouldn't give you one that would go that high. All right, so now we've got to balance this thing. And we had special balancing rules for combustion reactions. The rules were balance them alphabetically, and then there was the rule of 2. Okay, do I need to apply the rule of 2 on this one? Yes, I do. Okay, I have an even number of carbon atoms. That means I need to start the balancing with a 2. All right, 2 times 6 is how many? 12. All right, so I need a 12 over here. Okay, 2 times 14 is 28. 14 times 2 is 28. So I've got 28 hydrogens on each side. Now I can look at the oxygens. 12 times 2 is 24. Plus 14 more is 38. Okay, 19 times 2 is 38. All right. How are we doing on 4 and 5? Do we need a little more time for those? Okay. Okay, let's have a look at number 4 here. Okay, what kind of reaction is number 4? It's a synthesis reaction. 2 elements are combining to form a single compound. All right, those elements are chlorine and lithium, and they're combining to form lithium chloride. Okay, I would say our best bet here is to balance the chlorine first. There's 2 on both sides now. Now there's 2 lithiums on both sides, and we're done. Okay. How many people have done number 5? Okay, let's go over that one then. Okay, so on number 5 here, we've got what kind of a reaction? Double replacement. Everything's ionic. Okay, so this stuff here is magnesium fluoride. Whoop. Not fluoride, fluoride. I'm just going to write it the American way with no U. Okay, there we go. Plus cobalt 3 nitrates. Okay, and then I've got magnesium nitrate. I'm going to run out of room. Plus cobalt 3 fluoride. Okay. What should I balance first? Yeah, probably nitrate. It probably doesn't matter whether I do nitrate or fluorine first because they both have a 3 on them at some point in the reaction. Okay. So I've got 3 nitrates over here, 2 over here. So again, and very often your lowest common multiple when you're balancing is going to be 6. It's very common. Okay. So we're going to have 2 and 3. Okay, that gives me 3 magnesium. So I got to go back over here and make 3 magnesiums. That gives me 6 fluorines. Now I have 6 fluorines, and my cobalts work out to 2 and 2. Okay, is that looking like we can probably handle that? Okay, more often than getting the reactions written this way, you would get them written out in words. Okay, the reason that I do that more often is because it's more demanding on you. To be perfectly honest, it's a little bit more demanding. Okay, if you don't get this way, you have to write the formulas, and the swaps and drops are crucial then. Okay, so if you don't get the swaps and drops right, then you're not going to get the balancing right. Okay, so this way does tend to be a bit more difficult. Plus, when we're predicting the products of a reaction, I only ever write the reactants in words, and then you have to figure out what the products would be after that. We're not there yet, okay, but we will be. Okay, so for this first one here, let's do it together. So I've got copper 2 nitrate. Okay, so copper, and the Roman numeral tells me it's the 2+ copper is with nitrate, which is NO3. Okay, so I drop and swap. I've got CuNO3 2. Okay, reacts with magnesium. Okay, to form magnesium nitrate. And copper metal. Okay, have I dropped and swapped everything correctly? Pretty sure I have. This was a 2+, that's a 1-. This is a 2+, that's a 1-. So okay, should be okay on that. What kind of reaction is that? Single replacement. Okay, and is it balanced? It is, yeah. Okay, it's already balanced. All right, that sort of makes sense. Okay, so like I said here, if I give you a hydrocarbon that's beyond the prefixes we've gone over, I will just give it to you, okay, like I have here. So you don't have to write this out in words, okay? You just have to put this one into a reaction with oxygen where carbon dioxide and water are produced. Okay, give you a couple minutes here, try 7, 8, and 9, okay? See how we do on that. Okay, so on number 7, I've got C12H26. Is going to react with oxygen, and that's going to produce carbon dioxide. And I better leave myself room because those are going to be big numbers. What kind of reaction is that? Combustion reaction. Okay. So I've got to balance alphabetically, and I have an even number. Okay, so I've got to start like that. So 2 times 12 is 24. So now I've got 24 carbons. 2 times 26 is 52. Okay, so 26 times 2 is 52. Now I've got to look at how many oxygens I have on this side. So I've got 48 oxygens in the carbon dioxide, okay, plus another 26. Okay, so we're looking at what, 74? No, 72. Yeah. Okay, so that means 36 here. 36 oxygens. Okay. Everybody all right with that? You got 74? 70. Okay. I thought I don't always trust my math in my head, but sometimes I do. That sounds like that should be a commercial. When I do math in my head, I don't always know. Yay. All right. How many people have done number 8? Right. Okay, let's go over that one too then. Okay, so I've got lithium nitride breaking down. Okay, so lithium with nitride. Okay, nitride's -3, lithium's +1. So this is going to be Li3N. Okay, and it's breaking down into nitrogen and lithium. All right, here's one of the reactions where remembering which elements are special is crucial. Is nitrogen special? Yeah, it is. Okay, so I got to remember that this is N2, or I'm going to get the whole thing wrong. I'll be able to balance it probably, but it'll be wrong. Okay, because nitrogen comes like this when it's an element. Lithium doesn't. Okay, so now I've got to make this work. I could go over here and put a 3 beside lithium, but is that going to solve any problems for me? No, it's not. All right, so I'm going to put a 2 here and balance the nitrogens first. Okay, now my nitrogens work, and I can very easily put a 6 over here and have my lithium be balanced. Okay. All right, give you a few minutes on 9 and 10, okay, and then we'll go over those ones. All right, so for number 9 here, I've got hydrogen sulfide, which is an ionic compound, okay? So sulfide's -2, hydrogen's +1, so we got H2S, okay? And that's going to react with calcium hydroxide. Ca is 2+, okay? And hydroxide is a -1, that's why I'm putting it in brackets, so we'll have CaOH2. Everybody okay so far? All right, so this is actually what's called an acid-base reaction. Here's our acid, here's our base, okay? An acid and a base react always to form a salt of some kind and water, right? Which is what we've got here. Calcium sulfide, CaS, this is a -2 and this is a +2, so they balance out, and then we got water. Now, typically, what's easier in terms of balancing is to write water like that in this case. The reason we want to write water like that, it's easier to track where the parts of it came from. Okay, I have an H and an OH that are combining over here to make water. Everybody follow? Okay, so sometimes it's easier to track where everything came from by writing water as HOH. Okay, it's still H2O, but I'm writing it in a way that helps me track the parts better. Pardon me? It does matter, it's wrong. Okay, if I write Ca2S2, I'm saying the molecule has 2 calciums and 2 sulfurs in it, which it doesn't. Okay, it's 1 to 1. All right, so now I've got a balance. Okay, probably best to start with either hydrogen or hydroxide, doesn't really matter. I've got 2 hydrogens over here. How many do I have over here? 1. Okay, and that's the trick, right? It looks like there's 2, but remember, this hydrogen came from here. Okay, it's part of OH. This is why it's easier to track it this way. Okay, so I'm going to put a 2 here. That balances my hydrogens and my hydroxides. Okay, a little easier to track when you write it that way, as opposed to H2O, where, oh, where did it come from? Okay, so typically, if you've got an OH on one side and you got water on the other, write water as HOH, and it'll just be easier to keep track of everything. Okay, that'll balance it. It's done. Okay, that's the only number that we needed to add in there. All right, and this is, of course, a double replacement reaction. Okay, and then for number 10, okay, number 10, the whole purpose of number 10 is to remember the special elements. Is phosphorus special? Very, right? It's P4. Okay, and it reacts with oxygen, which is also special, O2. Okay, and that's going to produce triphosphorous dioxide. All right, so now I got some balancing I got to do. What should I balance first? Yeah, definitely phosphorus. All right, what's the lowest common multiple of 3 and 4? 12. Yeah, the lowest common multiple is 12. Okay, so if I put a 3 here, that gives me 12. If I put a 4 here, that gives me 12. 4 times 2 is 8. 4 times 2 is 8. Okay. All right, so that's what we're going to be doing for the next little while. Now, on Monday, okay, we're going to do the pre-lab stuff kind of in the last, let's say, 15 minutes of class or so. So I'll hand out the Chromebooks last 15 minutes, and I'll go over the, the variables and the hypothesis and all that kind of stuff. And you can look at what your observations chart will need to look like for the next day. Okay, then we'll come in on Tuesday morning. Okay, we'll have our quiz, and then we'll quickly go over to the lab and perform the actual procedure, get the data that you need, okay, and then come back over in whatever time we have left, which should be probably like 20 minutes or so. It really shouldn't take too long to mix the combinations we have to mix. Okay, come back over here, and then you'll have some time to work on the lab report then. Okay, another reminder is that on Monday, at the beginning of class, your lab report is due. So make sure that you have it done and submitted for the start of class. Pretty sure September 18th is Monday. Yeah. Okay, yeah, good question. Do you have to answer the class discussion questions? The answer is no. Okay, the class discussion questions are going to be discussed by us in class when I hand back the lab on Tuesday. Yeah, well, if we have time on Tuesday, I'll still have it like handed back to you, like returned after I'm done marking it, but we may not get a chance to go over the lab till Wednesday, just because I don't want to miss out on lab time on Tuesday. Okay, but we will discuss them in class. You don't have to do them as part of the lab report. Okay. All right. So what I want you guys to do is in the workbook, okay, on page, what page are we on here? Page 8. Okay, there's some stuff just kind of like what we were working on. So you write it out in words, okay, write the type of reaction and balance it. All right, so once you're working on those ones right now, I'll throw the key up here in a minute. Okay, so page 8 in the workbook, and I'll throw the key up here in just a sec. I'll also put the key in the stream for today so that you have access to it if you need it.
I don't understand. I don't know what happened or where. Or like just how the hydroxide turned into water exactly.
The hydroxide doesn't turn into water. This hydrogen joins with it because it's a double replacement reaction, right? So the metals switch places. So calcium ended up with sulfur and hydrogen ended up with
Then you
hydroxide.
have H2OH2, right? Because doesn't hydrogen still have two?
Well, but that's why there's a 2 here,
Okay.
right? Because if I look at this, H is +1 and OH is -1. If I drop and swap, it has to be HOH. It can't be H2OH2,
Right.
right? That's why I put a 2 in front of it. That accounts for the 2 hydrogens I got from here and the 2 OHs I got from here.
Okay.
Yeah?
Yes.
Okay, so all we did was switch the metals, and yeah, the new partner is
I
OH.
didn't understand why the brackets disappeared, but now
Oh yeah, because I don't need
Yeah,
them.
you don't
Right,
need
there's
them
no number outside.
Cool.